We want to look at logarithm of numbers less than 1, introduction. Now, what are the numbers less than 1? We have to take our minds back to the number line system. This is 0, this is -1, and this is 1. The numbers that are less than 1, they are this way, okay? You move this way. So numbers like 0.9, and you keep moving down to 0.1. all right? So we're not interested in negative numbers. So just between 0.1 to 0.9, these are the numbers less than 1. Even a number like 0.001 or 0.00089. So you observe something, that all the numbers less than 1, which we're interested in here, they must always start with 0 point something, okay? So all numbers that start with 0 point something, they are less than 1. So if you look at this, our list now, the numbers that are less than 1 here, we have this, and we also have this. All right. So for this particular logarithm, we're interested in these ones. But before we go deep, let's look at the introduction, starting with what? Standard form. Okay. So now, why are we interested in standard form? Because the value or the power of 10 will give us the characteristics of the number. So the logarithm of any number is divided into 2. Let's say something like this, 3.8341. This part before the decimal point is called characteristics, this way. Okay, characteristic. Then the part after the decimal point is called the mantissa. So together they give us the log of a number. Now the characteristic is gotten from the standard form, okay, while the mantissa is gotten from a log table. We'll get into that, okay. So quickly, let's look at what we have under standard form here. So for to express this number in standard form, we look for where the decimal point is and move it until we get to the first digit, which is a non-zero digit. So if we move this, we're going to move this from here now. We're going to move it 1 and 2. So our final answer will be 1.357 times 10 raised to the power of 2. When you move your decimal point to the left, is a positive power, but when you move it to the right, is a negative power. So that's the answer for this. For number 2 in standard form, if you check this, you will discover that there is no decimal point anywhere here. Now we have to remember, when a number doesn't have a decimal point, then we know for sure the decimal point is hiding at the last digit, okay? So here is where the decimal point is. So from this place now, if we move until we get to the first, this is how many times we're going to move. We're going to move 1, 2, 3, and 4 to 1.6599 times 10 to the power of 4. That's for this. For this one, the decimal point is here. There's no digit to move to, so we leave it where it is. So the answer for this is 6.9341 times 10 to the power of 0, since we didn't have to move. This is the first digit. Now for these ones that are less than 1, how do we get our standard form? So now for this one, we're going to move backwards until we meet the first non-zero digit. So this is 1, 2, and 3. So our number is 3.764 times 10 to the power of -3. So you see, the characteristics of this one is a negative, okay? So take note of that. Then for this one, similarly for this one, it will move this way backwards only once. So our standard form will be 9.81 times 10 to the power of -1. Finally, for this, we have to move. Let's count 1, 2, and 3. Please don't be tempted or be deceived by this. The first non-zero is this, not 7, okay? So the first one we meet is 3. Irrespective of the other zeros, we don't bother, so long as we get to the first non-zero digit. So from this one, if we move, this is 1, 2, 3. So the final answer is 3.0007512 times 10 to the power of minus. How many times did we move? 3 times. So you can see that for numbers less than 1, when you express them in standard form, the power of 3 is always negative. Okay, so that will lead us to the next thing. Alright, so let's go to the next thing. Now, the next we want to look at is the logarithm of these different numbers. Okay, so let's start with this one. 135.7. If I want to get the log, I will first of all express it in standard form in my head and note the power of 10. Okay, so if I want to shift this decimal, I'll shift it 1, 2. So that will be 2 point. I will now go to my log table and check 13 under 5 difference 7. Okay, the position of the decimal point doesn't matter. You combine the first 2 digits. Imagine the decimal point is not there. All right, so 13 under 5, if you check your log table very well, you are going to get 1303. If you follow that line for your difference, under difference of 7, okay, you're going to get 23. So you add the 23 this way. Okay, so when you add these digits, you're going to get 6231. So the logarithm is this now. So this is the mantissa. This part is the mantissa. This is the characteristic. So the log of this is 2 point this. Now similarly for this number starts with 0. So the characteristics will be negative. Alright, so if we try to do our standard form, we have 1, 2, 3, that's -3. But we don't write it as minus, write it as bar. So this becomes bar 3. Okay, bar 3 point. So you remove all the zeros and check 13 under 5 difference 7. So you see it's the same result is going to give us. Okay, so that will be 1326. That's for this. For this other one, the characteristics is 0, because if we are to change this to standard form, the power of 10 is 0. So we have 0 point. So 13 under 5 difference 7 is still 1326. Then finally for this, if I had to change this to standard form, I'll move from here. This is where the decimal point is. 1, 2, 3. So that will be 3 points. So 13 under 5 difference 7 is still 1326. So you can see different position of the decimal points. Look at the different results. Because the digits are the same, the mantissa will always be the same. The only thing that will change is the characteristics, telling us that the position of the points is different. But note one thing, okay? Note one thing, that whenever a number starts with 0, okay, 0 point something, the characteristic is always bar, which is -3. Okay, so take note of that. That's what we're doing in these problems here. So I'll see you in the next one. Cheers.